In this lab, I'm going to look at the second attribute that BGP uses to prefer the path for outgoing traffic, which is called local preference. The difference between this and the previous, which I used wait, is that wait is localized to a single router and is not exchanged. So when the prefixes are re-advertised internally, the wait is applied on each and every router separately, and it is local to the router, whereas the local preference, once applied, is distributed within our system. So for example, in this particular situation, I have rearranged my network, and local preference, once applied for the incoming prefixes from one AS, will be propagated to all the routers here in my system. So each one of them is going to be using the highest local preference for the exit for which it was applied. So in this situation, what I'm going to do is, let's go for R2, see what the BGP table looks like here. So currently, R2 show IP BGP is learning a bunch of prefixes, but the gateway to those prefixes is router 1. So this is the best path marked with the right angle bracket here. And the wait attribute for each of those is 0, locally applied 0. And if we don't use this one, if this one is equal for all prefixes number 0 here, the second that is going to be tested is the local preference. Now local preference will be exchanged between routers, so we'll see what the result is going to be. So if I go to, let's say, R4 and do show IP BGP, it's also the same thing. For all these prefixes, the R1 is the gateway here. So all those prefixes will be sent across R1. Let me now change that. Maybe I want to offload some traffic and use R2 as a gateway towards the internet as well. So for, let's say, certain prefixes, and for those maybe I'm gonna go for, let's say, 133, 133, those two prefixes. I would like the R2 to be the gateway for the traffic leaving AS500. So how do I do that? So if the wait attribute is identical for all of those, and it is, the second parameter that is checked is the highest value of a local preference. So what I'm going to do is I'm going to apply on R2 a prefix list with a route map that matches on those 133 prefixes. And once they are learned from Internet 2, I will apply the higher local preference than that currently is applied. So the default one is 100. Now let's go back here to R2. So it doesn't show actually here because this output only shows the local preference 100 for internally or iBGP sessions, but doesn't show for eBGP sessions. However, it's still the same 100 value default. Show IP BGP, let's say 133, 133, 10. So this is the eBGP peer, and the local preference is applied by default 100, and for iBGP peer, it's also 100. So let's change that around. So what I'm going to do now, I'm going to apply higher local preference, let's say 200, for those two prefixes, and I will apply the default 100 for all the rest learned from Internet 2. So how do I do that? Conf t IP prefix list, let's say subnet 133. Permit 133, 133, 10/24. That's exact match, and the other one is 2. So this matches on those two specific prefixes in BGP. Then I create a route map called for int2 permitting. In my clause 10, I'm going to say match on IP address prefix list sub underscore 133, and for those apply set local preference 200. So that's higher than 100 default, and if I apply this for incoming advertisement from Internet 2, R2 is going to propagate to all our routers saying I'm going to be the gateway for the destinations matched in this prefix list. For all the rest of the prefixes, so clause number 20, just permit them but don't apply any changes to those prefixes. Now I need to apply this in the BGP process for my neighbor. So 500 is neighbor is internet 2 is 10.1.22.54. I will apply route map now. Critical part, don't make any typos here, for all inbound advertisements. So obviously at this point, again, it's not working. I need to send a request to internet 2 so that it sends those prefixes, these advertisements once again. So for now, this is what it looks like. And for all these, show IP route BGP, still 1111 is the gateway right here. And in particular, those two I matched against in my prefix list. Now clear IP BGP neighbor, neighbor 10.1.22.54 inbound. So that should do it. And voila! Now the gateway for those two prefixes is now internet 2. So the reason being show IP BGP is because this one has now higher local preference than R1. Now here's what happens. This is going to be now propagated because the local preference is propagated to all routers. So if I, let's say, clear IP BGP, send it to out to all routers. So now at this point, all routers actually are learning that R2 is going to be the preferred gateway towards those two destinations. Let's see that. So let's go to R1, show IP BGP, and sure enough, here and here we see that. And if I go to R4 now, same thing. All of a sudden, for those two destinations, the preferred gateway is going to be R2, which was used to create a higher local preference for those two destinations. Same thing here. R2 is the gateway for all those. So that's how we can manipulate a local preference attribute to accomplish, in my case, the goal of offloading traffic towards the internet using now two different gateways.